Good morning, class. We are looking at College Algebra Chapter 8, Analytic Geometry, Section 8.3, Parabolas. So we covered the circles, the ellipse, the hyperbola, and now the parabolas. Objectives. Graph parabolas with vertices at the origin. Write equations of parabolas in standard form. Graph parabolas with vertices not at the origin. Solve applied problems involving parabolas. Recall when we were dealing with the conics and how we came up with those. Definition. Circle. A circle is the set of points in a plane that are the same distance called the radius from a fixed point called the center. So if the center is at 0, 0, the formula is x squared plus y squared equals r squared. This is the standard form. If it's centered at h and k, the formula is x minus h quantity squared plus y minus k quantity squared equals r squared. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent the two foci. Here's F1, here's F2. PF1 plus PF2 is fixed and it's equal to 2a. The formula is x squared over a squared plus y squared over b squared equals 1. If it's centered at h and k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. If a is larger than b, it's elongated along the x-axis. If b is larger than a, is elongated about the y-axis. The relationship between a and b and c follows Pythagorean theorem. So the one that is the larger follows that a squared either plus c squared is equal to b squared or b squared plus c squared equals to a squared. As a result, if a is larger than b, c squared is a squared minus b squared. If b is larger than a, c squared equals b squared minus a squared. Hyperbolas. A hyperbola is a set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. For every point on the hyperbola, the difference m minus n is the same constant. A hyperbola has two vertices. The vertices are the points where the graph crosses the x or y axis. Center, the point halfway between the two vertices, is the center of the hyperbola. The line through the vertices is called a transverse axis. The formulas are x squared over a squared minus y squared over b squared equals 1. Very similar to an elliptical formula, but there's a negative here. And as far as I'm concerned, I'm going to keep the b squared under y squared, even if we have y squared over b squared minus x squared over a squared, because this way, the formula for the asymptote doesn't change. It remains as y is equals plus minus b over a times x. And because c is always larger than both a and b, a squared plus b squared is equal to c squared. Whether it opens sideways or up and down makes no difference. Now, this is the hyperbola that opens sideways. This is called fundamental rectangles. If you connect the diameters, okay, this point to this point and this point to this point, it gives those lines that are known as asymptotes. If it's centered at h and k, again similar to an elliptical formula, x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1, and the rest of it. And now parabolas. Section 8.3, parabolas. Parabola. A parabola is the set of points in a plane that are the same distance from a fixed point called the focus and from a fixed line called the directrix. As a result, a parabola is the set of points P for which the distance from the focal point to P and the distance from P to D, the directory is the same. Meaning, if you have a parabola, if you pick any point on it, connect it to the focus, and drop a perpendicular to its directrix, this distance is the same as this distance. If you put it here, the same thing. Put it here, the same thing. Here, here, here. Anywhere you pick. This is where the focus is. This is the axis of symmetry. You can fold this, and the left side covers the right, or the right side covers the left. Here's the vertex where the axis of symmetry crosses. The focus is on the axis of symmetry, and this distance is called the focal distance. Now, if you look at this case, P is some point on a parabola, drop a perpendicular to its directrix, and the distance from the focal point is the same. So what is the focal distance? The focal distance of a parabola refers to the distance from the vertex the point where the axis of symmetry intersects the curve. Notice. To the focus along the axis of symmetry. So in short, this distance is the same from the vertex to the directrix. This distance is referred to as either P or A. So here's the vertex. Here's the focus. This distance or this distance. So let's go with this distance. And because by definition of a parabola, every point has the same distance from the directrix, these two are the same. Okay, let's actually go with a different color. This distance. If you're looking at this one, would be this distance. Versus this distance. Now, what I want to add is normally they are either called or A or P. I like to go with P representing the focal distance, in which case this equation becomes x equals minus P. Why do I go with P? Because as you recall, in intermediate algebra, in elementary algebra, when we were discussing parabolas, A represents the coefficient of a second degree term. And so let's discuss the equations. Equation of a parabola: vertex is located at 0, 0, focus is at 0, 0, A is larger than 0, remember A or P. The equation of a parabola with the vertex at 0, 0, focus at A0, and directrix having the equation x equals minus A, where A is positive, is y squared equals 4ax or 4px. And I rather go with P, and I tell you why in a moment. So take a look at this. This has the equation y equals 4px. This opens to the right. This has the equation y equals minus 4px when it opens to the left. A focal distance again is P or A. If it opens up with the vertex at 0, 0, or opens down, in this case, x squared is 4py. In this case, x squared equals minus 4py. So I want to remind you of algebra. Recall, we said here's the standard form: y equals ax squared plus bx plus c, or a times x minus h quantity squared plus k with the vertex at h and k, or x equals ay squared plus by plus c, or a times y minus k quantity squared plus h. This is when it opens up and down. This is when it opens sideways. This is what we learned. And because of that, I rather call this the distance P rather than A so we don't mix them up. So if you go with this format, y squared is 4px, or y squared is minus 4px, x squared is 4py, x squared is minus 4py. What we really need to know is the following. The relationship between a focal distance and this A is that P is 1 over 4A or A is 1 over 4P. Therefore, if you recall the formulas from algebra and you want to stick with that, all you have to remember is the relationship between A and P, and you can transition to this format. I'll show you as we go through some examples. Parabolas, lattice, rectangle. So we have the formulas. Here's the graph and the definition, which represents every point. If you connect it to the focus, drop a perpendicular, that distance must be the same by definition. So I'm going to call this P comma 0. And this line directrix, x equals minus P, the point that they connect would be minus P comma 1. Now, this distance is called the lattice rectum. So let's look at the official definition. The lattice rectum of a conic section, the chord through a focus parallel to the conic section directrix equals 4p. And the length, this length is equal to 4p. We're going to discuss that with more details in a moment. In other words, the line segment that passes through the focus. So here's the focus, the line that passes through the focus. And it's parallel to the directrix is called the lattice rectum. Its endpoints lie on the curve. By definition, the distance d from the focus to any point P on the parabola is equal to distance from P to the directrix. So if we look at this one, what do we notice? This distance is P, this distance is P by definition. Therefore, from here to here, or from to here becomes 2 times P. If this is 2 times P, so is this one, and from here to here becomes 4P. Believe it or not, that's the proof. Let's remember something with more details now. Parabolas have many applications in electricity, mechanics, and optics. We're going to look at them later on. This is the parabola that opens up. This is the parabola that opens down. And as you recall, we've gone over that, but again, it's worth mentioning them. Recall equations of parabolas opening or down, up or down. Here's the formula: y equals a times x minus h quantity squared plus k. The vertex is located at h and k. The parabola opens up if a is positive, down if a is negative. The axis of symmetry, x equals h. So this is what we learned in algebra. The equation of parabolas opening left or right. This is to the right. This is to the left. X equals a times y minus k quantity squared plus h. Vertex is still the same point hk if you write it in this format. The parabola opens to the right if a is positive, and to the left if a is negative. Axis of symmetry, y equals k, because this is a, in essence, horizontal parabola, vertical parabola. And again, these are the formulas that we have seen. Nothing brand new, just reminding you exactly what we saw in algebra. We want to compare and contrast to what we are discussing here. So again, recall from algebra, here's example one. Given the function f of x equals x squared minus 6x plus 8, or x minus 3 quantity squared minus 1. Normally, we call this standard form, we call this vertex format, because right away the vertex is located at 3, 1. Determine which way the graph opens. Find the vertex, axis of symmetry, and draw the graph, find the domain, and range, so on and so forth. So analyze the graph in essence. So first and foremost, A is 1. You can look at it here or here, which means it opens up. The vertex, if you look at this formula, I hope everybody remembers this formula, is located at 3, negative 1. And because the vertex has x equals 3, the axis of symmetry, or short axis, has the equation x equals 3. So we already know this is a vertical parabola. It opens up. So the vertex 3 and negative 1, the y-intercept, if you set x equal to 0, it's easier to look at this one, becomes 8, meaning 0, 8. The x-intercept, you have to set y or f of x equal to 0. Again, it's easier to set this one equal to 0. Factor it into x minus 2, x minus 4. Which results in x being 2, x being 4. 2 means 2, 0. 4 means 4, 0. Those are the intercepts. Let's write the table of summary. Here's your y-intercept. Here's one of the x-intercepts. Here's the second one. Here's the location of a vertex 3, negative 1. And here's another point. I'll discuss that in a moment. So you put those points in. You start with the vertex located at 3, negative 1. You put the y-intercept at 0, 8. You put the two x-intercepts at 2, 0 and 4, 0. Here's what is interesting about parabolas. We know the axis of symmetry has equations x equal 3. And so this distance, if you go the same distance, must have the same y coordinate. So it gives rise to a point with the same y coordinate as the y-intercept, which is 8. This distance is 3. Another 3 results in 6 and 8. That's how we get to this point. In other words, if you pick a point here, then corresponding to that, using the vertical, axis of symmetry, you can figure out more points. And of course, if you graph it, looks like that. Any parabola that opens up or down, the domain is all real numbers. But the range, it depends. If it opens up from the y-coordinate of the vertex to infinity, if it opens down from negative infinity to the y-coordinate of the vertex, and therefore this has the y-coordinate negative 1, it's going to go from negative 1 to infinity, and negative 1 takes a bracket, is half closed, half open, because negative 1 is included. I want to continue with this and find the focus, directrix, and the 2 points that define the lattice rectum, all of the above. To do that, we have the graph, we have the vertex, we have the axis of symmetry, we have the equation, and we know it opens up, we know the intercepts, you name it. Everything from the previous page There is nothing brand new here. Now, before we move on, I want you to know when a parabola, basically the focus is inside. You can think of it as inside. So it's inside the parabola and it's along the axis of symmetry. Just remember that, inside. If this is the parabola, this portion is inside, everything is outside. So it's somewhere here. That's the idea. So, and when it's inside, when you figure out where the focus is, then directrix goes the opposite side and it's a line, which is perpendicular to its axis. So you need to figure out the focal distance. Now, remember where the focus goes. The focus is on the same line, but has a distance of focal distance are called the P, as you recall. And P, I said it's 1 over 4a if we go with this format. We know a is 1. So P is 1 over 4a. A is 1. So 1 over 4 times 1, 1/4. So what it means is that we know the vertex, which is located at this point, 3, comma, -1. We move up by this much. If you want to move up by this much, you're going to keep the x coordinate unchanged and you're going to add this number to -1. That's all there is to it. So the vertex, you write the x coordinate, you write the y coordinate, and you add the p, whatever the value of p is. And that is -3/4. And that is the location of the focus. Okay. Now, remember the directrix. The directrix has a horizontal line, has an equation y equals a number. And it's the same distance, p, going down. So if you look at, again, the y coordinate here, now going down by p units, that means subtract this number from -1. You should know, again, where your directrix is, which gives you -5 over 4. D has the equation y equals -5 over 4. Here's the line. So I hope everybody's okay with that. Now, if we look at this equation, y equals x minus 3 squared minus 1, if you move the -1, becomes y plus 1. This is the format that they want. X minus h quantity squared is 4py minus q. If we want to go with this form. Now we want to discuss the lattice rectum. So lattice rectum, what color can I use here? Is this line. We want those points. So y equals -3/4. And if you look at this point and this point, which is, again, look at where the focus is, draw a line parallel to the directrix or perpendicular to the axis of symmetry, where it crosses the parabola. Those are the 2 points we are looking for. So what is the x coordinate here? I don't know. What is the x coordinate here? I don't know. But the y coordinate for both of them is the same as the y coordinate as focus. Focus has the y coordinate negative 3/4. So all you have to do into the equation of a parabola, because it is on the parabola, let y be negative 3/4. If you replace the y with negative 3/4 here or here, you can calculate the x, and x becomes 5/2 and 7/2. I'm going to leave it for you to show that. And so the 2 points have coordinates 5/2 and negative 3/4, 7/2 and negative 3/4. I'm going to show you a second method. We know the focus is located at 3 and negative 3/4, which means the y coordinate is equal to negative 3/4. If we add plus minus 2p, remember the p is 1/4. If you multiply it by 2, you get 1/2. So if you add and subtract that from the x coordinate, meaning x minus 2p, that means 3 minus 2/4. I'm putting 2/4 because I want to make sure you understand 2 times 1/4. And x plus 2p, x 3 plus 2/4, we get those numbers. Why is that? Because we've shown this distance is 2p, everybody. From here to here is 2p. Remember, latus rectum, the total length is 4p, half of it is 2p. So perhaps it's easier to go back to the focus and the x coordinate, add and subtract 2 times p. That's the second method. So there are two methods that you are exposed to. You decide which method you want to use. Let me erase my. So these are the 2 points we are looking. We want to graph x equals minus y squared plus 2y plus 3. And right away, you should recognize this quadratic with respect to y. That means it opens sideways. This is negative. A is -1. It makes it open to the left. So just to give you an idea. As far as finding the vertex, one easy way would be y equals minus b over 2a, because it's quadratic with respect to y. I hope you remember when we had it quadratic with respect to x, we would say x equals minus b over 2a, but now y is minus b over 2a, which is the k coordinate, which is the k, if you will. So minus b over 2a, so minus, this is a -1, this is b +2, this is c +3. So minus 2 over 2 times -1 over 1. So that is the k coordinate, the y coordinate of the vertex. If you plug in, you find the x coordinate of the vertex. So minus 1 squared plus 2 times 1 plus 3. 1 squared is +1, negative makes it negative. With 2 is positive, 1 with 3 is +4. And so the coordinates of the vertex is 4, 1, 4, 1. A is -1, and therefore parabola opens to the left. To find the x-intercept, you set y equal to 0. When y is 0, x becomes 3, and therefore you have 3, 0. To find y-intercept, x-intercept, you set x equal to 0. To find y-intercept, you set x equal to 0. And to solve this, you're going to bring this to the left to put this in a descending order with the coefficient of second degree term being positive. This becomes y squared minus 2y minus 3 equal to 0. You factor, you want two numbers. The product is -3 and the sum is -2. So y is either 3 or -1, resulting in 0, 3, 0, -1. The summary table, we have the following. We have 3, 0, 0, 3, 0, -1, 4, 1. We have all of the above, and we start with the vertex. The vertex is located at 4, 1. Three, 0, the x-intercept. We have two y-intercepts, 0, 3, 0, -1. So this is the parabola that opens to the left. Here's the axis of symmetry. And if need be, you can figure out the rest of them if they ask for focal distance. By the way, you should recognize the focal distance is somewhere here. The focus is here, and here's your directrix, and you can work on that. So let me actually. So again, where is that? I don't know. We got to figure it out. And here's the directrix. Okay, but this distance is the P, which is 1/4a, and you should be able to figure it out from there. Remember, A is negative. So from the vertex, you go to the left by this distance. You go to the right, and that gives you the equation of a directrix, which is a vertical line. So just so from here, okay. So from the vertex, if we look at the vertex here, the x coordinate is 4. If I subtract 1/4, I get 3/4. And this is 3 3/4. So I get 3 3 3/4 and 1. And if I add 1/4, I get this equation for the directrix, just in case. All right, let's move on. Finding the equation of a parabola and graphing it, find an equation of a parabola with the vertex at 0, 0 and focus at 3, 0. Graph the equation, find the focus, directrix, and 2 points that define the lattice rectum. And we have all those equations. And so let's take it from there. Here's the vertex at 0, 0. Here's the focus at 3, 0. Remember, the focus is inside the parabola. Right away, it tells you that it opens to the right. V has coordinates 0, 0. F has coordinates 3, 0. We write it. And again, just because of these two pieces, we should recognize that it opens to the right. This distance is the focal distance, which I'm going to call it P. I'm not going to use A. P equals 3. So if distance is 3, for the directrix, this distance must be also 3. Which gives us the line x equals -3. x equals -3. So this one is the directrix. We go with the algebra. X equals ay squared because it's centered at the vertex is at 0, 0. In essence, we are looking at one of these two, and this is the one we are looking at. So it's ay squared. We know p is 1 over 4a, and it's 3. 1 over 4a is 3. So a must be 1 over 4p or 1 over 12. So p is 1 over 4a and is 3. You can interchange a and p. So a becomes 1 over 4 times p. We know p is 3, so makes it 1 over 12. So here's the equation that we've used in algebra now. In college algebra, we can rewrite this. If we multiply both sides by 12, we get y squared equals 12x. So this is in essence, if we look at this one, everybody is using this formula. Notice 4px and p is 3, 4 times 3x. Okay. Or we can say we are using this. All right. Now for lattice rectum, remember the lattice rectum is somewhere, okay, here. If the focus has coordinates 3, 0, lattice rectum, the endpoints are somewhere there which we don't know the coordinates. We do know, however, it has to have an x coordinate the same as the focus. If x is 3, find y. You can use one of those formulas. So y squared is 12x, 12 times 3, 36, makes it plus minus 6, and the coordinates are the same x coordinate, and these are the y coordinates, 3 minus 6 or 3, 6. And of course, we said it opens obviously to the right, and that's good enough to give us the graph. So x equals -3, the vertex, the focus, the 2 points, the end points that we discussed. Again, please understand, class, that this distance, see, from here to here is 4p, right? The lattice rectum has a total distance of length of 4p. So from here to here is 2p, from here to here is 2p. And we know p is 3, 2 times that is 6. So same as this, go 2 times p up gives you 3 and 6. 2 times p down gives you 3 minus 6. So go back to the focus. Go back to the focus. Here's the second method. Given the focus with coordinates 3, 0, which makes the x coordinate 3, add plus minus 2 times p, which means plus minus 6, to its y coordinate. The y coordinate is 0. Add 6, subtract, you get those 2 points. Again, I'm showing you both methods. You figure out which method you want to use or which one is easier. Analyzing the equation of a parabola where f of x squared plus bx plus c, or a times x minus h quantity squared plus k. Analyze this equation, x squared plus 4x minus 4y equals 0. To analyze a parabola, you really have to, the very first thing to come up with is the vertex. And there are various ways of approaching that. But in any event, we are going to put these two together. And completing this square means I need to add a number to complete this square. And I'm going to write this as b equals 4 divided by 2 is 2. Squared is 4. We can add 4 to both sides, or we might say we're going to add and subtract, same side. And so you should know this is x and b over 2, whatever the sign is. X plus b over 2 quantity squared, that means x plus 2 quantity squared, minus. Now, if we divide both sides by 4, this becomes y. This is 1/4, this is minus 1. Going with this formula. So what happens is now you have a lot of information. A is 1/4, the vertex is at -2, -1, and this thing opens up because it's quadratic with respect to x. So again, here's the vertex, -2, -1. Because A is positive 1/4, it opens up. So the vertex is located at -2, -1, and it opens up. That means the focus is somewhere inside, and the directrix is a line beneath that. So we need to find the focal distance, and we know the relationship is P equals 1/4A. This is very important, everybody. Let's see what color do I want to use. This makes it nice and easy. As long as we remember that, the transition from one format to next is easy. So P is 1/4A. And here's A. A is 1/4. 4 times that makes it 1. So P is 1. Maybe I write this. So A is 1/4. It makes it pretty easy. So we know the focus, therefore, is at -2, 0. Because it's inside. This opens up and it's inside. So take this up by p units. So from the vertex, add 1 to the y coordinate, you get -2, 0. So again, one way to take care of that, say, I don't know where the vertex is, it's somewhere here. And I don't know what the equation of a directrix is somewhere down there. And remember, this distance is P, this distance is P. I would do that and then, of course, make it look good. So the y coordinate is -1. Bring it down by 1 unit, make it -2. So y equals -2. I'm gonna, so that would be the focus. And let me erase my line. It's horrible. So from the vertex, you go p units up. That gives you the focus. You go p units down and you come up with a line. All right, we can rewrite this by moving -1 to the other side, making it +1 and times 4. And this is the format. X minus h quantity squared equals 4py minus k. So the formats are as follows. These are the two formats. As far as the lattice rectum is concerned, wherever the focus is, and remember, this opens up, right? So when it opens up somewhere here and there, the same y coordinate as this point, the focal point, and you find the x becomes 0, -4, 0, 0, -0, 0, and -4, 0, and here's the graph. So that's the focus, that's the vertex, that's y equals -2 the directrix. This is the axis of symmetry, x equals -2. And again, the second method for lattice rectum. The focus is located at -2, 0. The y coordinate is 0, and it's got to remain as 0 for any point on this line. The x coordinate 2 times a p, which is 1, 2 times p makes it 2 times 1, 2. So you are going to add 2 to this and subtract 2 from it. When you add 2, you get 0, 0. When you subtract, you get -4, 0. Again, I don't know, you don't have to do both methods, and I don't know which one you find it easier, but if you know both, it's really helpful. Either way is fine, of course. Find an equation of a parabola with vertex at -2, 3 and focus at 0, 3. Graph the equation, find the directrix, so on and so forth. So analyze the graph. So let's see what we have. We have the vertex, -2, 3. The focus at 0, 3. The focus is inside the parabola right away. Because of that, you know the parabola looks like that. So just to give you an idea, one thing you can do is say, okay, I don't know how the graph looks like. I have a rough estimate of looking like that. And I have this one as the directrix, and I have this one as a line of symmetry. So that those two pieces of information should give you all of that. But in case, so let me just erase now, of course. So here's the vertex at -2, 3. Here's the focus at 0, 3. And therefore, it opens to the right. The focal distance is 2 because of the location. So we want this distance from the point -2, 3 to the point 0, 3 is clearly 2, and that's the P. And so the x coordinate for this one is -2. We go to the left of it, and the line, therefore, x equals -4 is the directrix. X equals -4 is the directrix. P is 1 over 4 times A, and we know it to be 2. Again, this is the relationship. P equals 1 over 4A, and we know it to be 2. So it makes A equals 1 over 4 times P, or 8, 1 over 8. And it opens to the right. We can go with that formula if you will. X equals A times Y minus K quantity squared plus H. We have the A as 1 over 8. We have the location of a vertex. So 1 over 8 Y minus 3 quantity squared minus 2, according to that formula. And this is what we have learned in algebra. If you move things around, in other words, move the negative 2 here, make it plus 2, multiplied by 8. This is what we get. And therefore, what we are looking at is this one for this equation. Okay, just to let you know, as far as the formula is concerned, what we are dealing with here. And just for the sake of argument, this was, I'm going to write it up here because of, I don't have enough room, so I put it up there. Y minus K quantity squared is 4P X minus K. So that's, there we go, right? All right. Lattice rectum, and it will help us with the graph. The focus is located at 0, 3, and we know it opens to the right. So just for the sake of argument, you can even do this. You say, okay, I don't know where the endpoints are, but somewhere here, and I'm making it up, somewhere here. The point is, by definition, the lattice rectum is that the endpoints, okay, meet there, and this distance is 4P, and each one is 2P. And now let's use that information. So F has location 0, 3, and the other 2 points which we don't know we are looking for, they have the same X coordinates, but Y is missing. So you put it into the equation, either this one or that one, it doesn't matter. And if you go with this, when X is 0, you get 16. So Y minus 3 is plus minus square root of 16, or 4. And these are the answers. And let me clean up. And now we have those 2 points we were looking for, and here's the graph. As you can see from the graph, we have the location of everything, including the directrix, the vertex, the focus, the end points, 0, 7, and 0, minus 1, the end points of the lattice rectum. And as I mentioned, the other method is that because the focus is at 0, 3, and because P is known to be 2, and because this distance is 2P, just 2 times P, which is 2 times 2 equals 4, whatever the Y coordinate is, go 2 times P units up and down. 2 times P, 4, and 3, 7. 3 minus 4 is -1. So that may be easier. or not. That's your choice, everybody. Solve applied problems involving parabolas. The optical property of a parabola has many practical applications. Parabolas display an extraordinary attribute known as the reflection property, utilized in a wide array of applications ranging from a car headlights to satellite dishes. In a car headlight, light coming from a single source is directed into a focused beam. This is achieved through the reflection property, which dictates that any ray parallel to the parabola's axis will reflect off it and converge at the focus. Conversely, a ray passing through the focus will reflect off the parabola in a manner parallel to its axis, ensuring that light originating from the focus is projected forward in a straight line. If a light source is placed at the focus of a parabola, and that's really the key, you want to pay attention to this concept. If a light source is placed at the focus of a parabola, the result will be parallel beams of light directed outward along a parabola axis. This is how projectors, car lights, flashlights, headlights, and searchlights work. Satellite dishes do the opposite. They collect electromagnetic rays as they arrive and concentrate them on one point, hereby obtaining a strong signal. Headlights, reflectors, and satellite dishes are designed so their cross-section are parabolic in shape, and the point of collection or emission is the focus of the parabola. So I want to explain this concept, everybody. If we look at what I have for you here, the idea is that this is in the shape of a parabola. It's a parabolic shape, and it's a focus. If the light source here, as it hits the walls, then it goes parallel to the axis of symmetry, rays of light. So that's a good idea for lights, searchlights, and so forth. On the other hand, if rays, magnetic rays come in and hit the wall, they concentrate into just one single point, which is the focus. And that is the property of parabolas, and they use them in optics as a result of this. For example, a satellite dish is shaped like a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point, namely that focus that we mentioned. Where the receiver is located, if the dish is 8 feet across at its opening and 3 feet deep at its center, at what position should the receiver be placed? The receiver should be placed at its focus. It has to be at the focus of a parabola. Now, for the ease of operation, here's the setup, everybody. Let us set up a parabola whose vertex is at the origin and opens up. Why the origin? Makes it easier for the sake of calculation. And it looks like that. We have the x-axis, the y-axis, the vertex is 0, 0 here. It is like this. We know this is 8 feet. So somewhere here, if this is 8 feet, 4 feet to the right, 4 feet to the left, gives you -4. And this is 3 feet deep. So I hope you realize from here and the given information, this point has coordinates -4, 3. This point has coordinates 4, 3. This is the vertex at 0, 0. And this is the focus with coordinates 0, P, which is missing. So the bottom line is we are looking to find P, and this is where we are going to put it, because as the rays come in, they concentrate right here. where the receiver is. So this opens up y equals ax squared. Remember, we use this formula with h and k being 0. Use one of those pairs. Actually, I want you to know this comes from the fact that the vertex is at 0, 0. So in essence, you have this point. If you don't have the vertex, you need 3 points to find the equation. But since we have the vertex, we need 1 more point. So one of this is good enough. So let's say we use this 4, 3, which means you are going to replace the y with 3 and x with 4. 16 a, and a is 3 over 16. And the equation is y equals 3 over 16 x squared. So this is the equation of a parabola. We know P is 1 over 4a. So P is 1 over 4a makes it 4/3. And 4/3 of a foot, or 1 foot 4 inches. So that means we are going to put it here. From the vertex, we go up by 1 foot 4 inches. The receiver should be located 1 foot 4 inches from the base of the dish, because the base is the vertex, okay, along its axis of symmetry. So it's somewhere there, 1 foot 4 inches. Analyze the equation of y squared equals 8x. Let's look at that. Y squared equals 8x, which gives you the vertex at 0, 0 right away. Or y squared equals 4px. The vertex is at 0, 0. It opens to the right. Remember, when y is quadratic, has exponent 2, then it either, and x is not, it either opens to the right or to the left. X is 1 over 8 times y squared, and 1 over 8 is positive. Let me write that in that format for you. So this means x is 1 over 8 y squared, and that's why it opens to the right. So we know the vertex, and it opens to the, so you already know, again, just to give you an idea, okay, and I'm going to erase that. So it should look something like this. Somewhere here, we don't know the exact location, is the F, and somewhere here we have the directrix, x equals something. So we have a lot of information because of that. Now we're going to figure out what's going on, because again, you can say a is 1 over 8 and p is 1 over 4a, or y squared equals 4px, which 4p is 8, p becomes 2. There are many ways of calculating the p. At this point, I'm going to leave it for you to figure out. You can go with this, and then p becomes 2. If p becomes 2, then the focus is 2, 0. So this distance is 2. And then makes this distance 2. And the directrix must be x equals -2. So let me actually clean up this part. I'm going to leave the rest of it. So the focus is at 2, 0. The directrix makes it x equals -2. Again, it's really a good idea that you have a rough sketch, and then it makes it easy to see everything else. Let's discuss the lattice rectangle. The focus is at 2, 0, and it opens this way. So again, let's have the graph so you see what I mean. So those are the endpoints of the lattice rectangle, where we don't have the coordinates, but we do know the x for this guy is 2. So the x for this 2 must be 2. So go to any of those formulas, let x be 2, and find y, and you get 2 minus 4 and 2 plus 4. Again, I'm going to erase that. And so we have those two pairs, and that's the graph. So it really makes it very easy. My suggestion is that the moment you have the vertex and a focus, it should roughly give you the shape, the vertex, and everything else. And of course, that gives you an idea of whether you add or subtract the number and so forth. Here's the second method again to find the LR, short for lattice rectangle. We know focus is at 2, 0, and we know the x coordinate is 2. And as far as the y coordinates, you go back to the focus, and you do plus minus 2 times the p is 2, 2 times 2 is 4. So plus 4 and minus 4, and that's exactly what we get here. So again, I keep mentioning both ways because you have to figure out what's easiest for you and come up with the answer. But now that you're exposed to it, it makes life nice and easy. Now we want to indicate the type of conic the equation represents. All of these are conics, but what are they? Now, first and foremost, if you want to come up with a precise answer and you want to answer it with details, you have to come up with a standard form. However, I'm going to go over a fast way of answering it. This one is a circle. Why is that? Both x squared and y squared are there. So we have x as well as y with exponent 2. They are both quadratic. And they have equal, identical coefficients on the same side of the equation. Part B is a hyperbola. Again, they both have x squared and y squared. So both x squared and y squared are there with opposite coefficients on the same side of the equation. If it's on the same side, all they have to be just having opposite signs. One is positive, one is negative. Doesn't matter which one. 6x squared plus 30y squared equals 180. This is an ellipse. How do we know that? Again, we have x squared and y squared. So both x squared and y squared are there with different coefficients and the same sign on the same side of the equation. So notice when you look at the equations, they do have the same sign, but they're different. See, they have the same sign, but they're identical. It becomes a circle. They have opposite signs, becomes a hyperbola. So for this one, we're going to move this. The moment you move this, see identical coefficients for x squared and y squared, therefore it's a circle. So this is the same as this one. Both x squared and y squared are there with equal coefficients on the same side of the equation. However, if you look at parts E and D, both of them, only one of those variables, x, either x or y, not both, are quadratic. They have exponent 2. So when x has exponent 2, it either opens up or down. When y has exponent 2, it opens to the right or left. Just remember that. So this is a parabola and it opens up. Why is that? There's only one quadratic variable, x squared. Okay. And you know how to figure out if it opens up. A is positive. In fact, if you divide both, if you move the 7 and divide by 5, A becomes 2. And when y has degree 2, it opens sideways. In this case, opens to the right, again, because A is positive. There's only one quadratic variable. So in short, when both of them are quadratic, everybody, if these coefficients are identical, when on the same side, it's a circle. If they are different, it's an ellipse. If they have opposite signs, one is positive, one is negative, is hyperbola. It's only one of them is of degree 2, is a parabola. If x is of degree 2, it opens up or down. If y is degree 2, it opens sideways.